Waiting for Dr. H to come in, so they'll just have to pick it up. It'll be great.
Okay, so let me give you some examples of the type of sum that I'm talking about. You have a sum, n equals 1, such that 2 to the 5 to the 8, 25n plus 5, 8, all the way to 7. This is not that hard to solve, but if you do, you will find that it equals to 7 over 2. Another example, n equals 1 to 7. 7 to the 8, 49 to the n plus 7 to the 8. You will find that that is also equal to 7 over 2. Again, this is not that hard to solve, but what if I give you something like this, where you have from n equals 1, 5 to the 2008, 25 to the n plus 5 to the 2008, and I make the upper bound 2007. A little bit harder, but you will find that it's equal to 2007 over 2. So, I have a lemma. So, this is saying, let's consider any A, B, and C positive integers. Sorry, I didn't touch that. And we have square root of A to B. Raise this to C plus square root of A to B. Now if we add another one, similar to this, take the square root of A to the B, but raise this to the B minus C plus square root of A to the B. This will always give you 1. Doesn't matter if you have 5, 5, 25, 7, 7, 49. Will always give you 1. So this is easy to prove. We just multiply by a common denominator. So we have A to the C plus B minus C, so A to the B, plus square root of A to the B times A to the C, plus square root of A to the B times square root of A to the B, then plus, see I did this times this times this, so okay, so A to the B minus C times square root of A to the B. And this is all over. If you do out the multiplication, I have it right here. Square root of A to the B plus square root of A to the B times square root of A to the B plus A to the C square root of A to the B plus square root of A to the B times square root of A to the B. Now, bear with me, this is kind of long, but everything cancels and it gives you 1. So, I have a theorem. Come over here. Now this time we're going to have A and B we're going to have that the upper bound is 0, not good. So this is saying that if you have a sum, n equals 1, such that we have a square root here, and we have a to the n plus square root of a to the b, and we raise this to 1 less than b, this will always give you c minus 1 over 2, which is why we have this is, these are the same. It doesn't matter if it's 5, 7. So, to prove this, we notice that when n is equal to 1, we get just a plus square root of a to the b, square root of a to the b up here. Now if we add this when a is equal to b minus 1, n is equal to b minus 1, plus square root of a to b, square root of a to b. We know by the lemma that this is going to give us 1. So it all boils down to this number right here. Now, it's either even, in that case, b minus 1 over 2, or it's odd, b minus 1 is odd. If it's odd, we're going to have an extra term. And this occurs when n is equal to b minus, or b over 2. So, and this will always give us 1/2, since this here is a to the b over 2. And then this is going to be a to the b over 2 plus a to the b over 2. So this will always give us, this extra term will always be 1/2. So we have b minus 1 over 2 minus 1/2 of these terms that each total to 1. So we multiply by 1, or plus the term that always equals 1/2. This gives us b minus 1 over 2. Now, if b minus 1 is even, well, we're just going to have b minus 1 over 2 of these terms that equal 1. So we multiply by 1, and we get b minus 1 over 2, which is the theorem. So this all started from Math Horizons magazine, because this was a challenge problem actually in the magazine. So there's many ways to solve it, but I realized I made a bunch of smaller problems, and I realized that it's kind of funny that it's always this number divided by 2. And then, yeah, so it turned out that it was true. So, that's the truth. Is there any questions?
I just wanted to make my, she showed me her paper beforehand, like about 2 hours ago. That was her motivation for doing this proof on her own. That's how it's called. This whole proof is something she did.
Yeah, this is my theorem. I did this in the woods, actually, over the summer. I found this.
Was it Testament?
But I did this probably 2 years ago.